Alright, in this video we'll do a couple more example problems on implicit differentiation, and both of these examples are very similar to problems that have appeared on AP exams in the past. And here's the first one. X squared plus y squared is 25. Find d squared y dx squared at the point 4, 3. So this notation here means the second derivative, the derivative of the derivative. So we're trying to find the second derivative of y with respect to x at this point. So let's find the first derivative, and that's going to be done implicitly, so we'll differentiate the left and the right. So on the left we differentiate, we get 2x plus 2y times y primed by the chain rule equals the derivative of 25, which is just 0. And I can divide both sides here by 2 just to simplify. And on the right, 0 divided by 2 is just 0. And on the left, the 2's simply go away. So I have x plus y times y primed equals 0. And let's solve this for y primed. So y primed is negative x. So y primed is equal to negative x over y. Now, that's the same thing we got in an earlier problem when we had a circle. Okay, so y primed is negative x over y. So at the point 4, 3, y primed is negative 4 over 3. So that's the derivative at the point 4, 3. But we need to find the second derivative at the point 4, 3. So what I'm going to do is take this equation, I'll use the simplified version rather than this one, and I'm going to do implicit differentiation again. So I'll just make a note of that. Differentiate again. And when we do that, I'll differentiate term by term. The derivative of x is just 1 plus the derivative of this product. So I have the first, that's the y, times the derivative of the second. And the derivative of the y primed will be y double primed. Plus the second, which is y primed, times the derivative of the first. And the derivative of y is just y primed. And I have equals 0. Now just note this y primed, y primed. I'm going to leave it written that way. I'm not going to write it like this. I'm not going to write y primed squared, because you can understand why that is confusing. That looks like y to the 12th. So rather than have a notation that could be so easily misinterpreted, I'm just going to keep it like that, y primed times y primed. Now I'm trying to find the second derivative, which is this right here, y double prime. So let's just do the algebra to solve for that. Y times y prime prime is going to be negative 1 minus y primed, y primed. So y double prime, what I'm looking for is negative 1 minus y primed over y. And then at the point 4, 3, this is going to equal negative 1 minus y primed, and y primed is this, negative 4 over 3. So negative 4 over 3 times negative 4 over 3 is going to be positive 16 over 9, but I still have this minus sign right here from the numerator up above, and then all of this is over y, and y is 3. So I have negative 1 minus 16 ninths over 3. Let me get a little more room here, and we'll just simplify this. So this is going to be negative 9 ninths minus 16 ninths over 3. And negative 9 minus 16 is negative 25. So I have negative 25 ninths over 3, which is negative 25 over 27. And that's my answer. The next problem, Find the slope of the line tangent to the curve y cubed x plus y squared x squared equals 6 at the point 2, 1. So I need to find the derivative of y with respect to x. That will be the slope of the tangent line at this point. So we're going to differentiate this implicitly, and when I do the derivative on the left side, I'll do the derivative of each term, and each term is a product. So I'll end up using the product rule 2 times. So over here, let's do the derivative of y cubed x. That's the first times the derivative of the second plus the second times the derivative of the first, which will be 3y squared times y primed. Now we need to differentiate the second term. So that will be the first, which is y squared, times the derivative of the second, which is 2x, plus the second, which is x squared, times the derivative of the first, which is 2y times y primed by the chain rule. And all of that will equal the derivative of the right side, which is just 0. Now we need to algebraically solve for y primed, which shows up here and here. So let's get these two terms together on the left and all the other terms over on the right. So I get 3x y squared times y primed. That's this first term, just rearranged a little, plus 2x squared y times y primed equals, I'll take this term over to the right, and I'll write it as negative 2xy squared minus y cubed. And then on the left, we can factor out the y primed. Y primed times 3xy squared plus 2x squared y equals that right side over there. And then I'm going to just divide both sides by this. So that's going to disappear from the left and end up in the denominator on the right. So I'll just put 3x y squared plus 2x squared y down there. And that's y primed. Now I need to find the slope at the point 2, 1. So I'm just going to put 2 in for x everywhere an x appears there, and a 1 in for y. And having a 1 there is kind of nice because all these y's and the y cubed and y squared and all of that will just go away because they'll just be factors of 1. So at this point, 2, 1, this is what I get. I have the negative 2 up there times x, which is 2, times y squared, which is 1, minus y cubed, which is 1. And all that is over 3 times x, which is 2, times y squared, which is 1, plus 2 times x squared, which is 4, times y, which is 1. So this will be negative 5 over 6 plus 8. So negative 5/14 is my answer.